and welcome to Safety Mantra, the ultimate channel for health and safety professionals. Aim of this channel is to enhance the knowledge of health and safety professionals. Not only that, and also we provide assistance to develop HSE procedures, plans, checklists that is really required for you when you're working in the construction site, especially in the oil and gas industries. What do you need to do that? Drop your messages in the comment box when we upload the videos with your email address so that we can reach to you and provide you necessary assistance. This is free of cost. The only thing we need from you to share these videos and get a good reach for this channel. This channel is for you guys. Please do watch and support us. The Safety Mantra, the channel for you guys. Thank you very much for your support and stay tuned with us.
Confined Space Part 3 Gas Monitoring. As we discuss many things in Part 2, especially about the ventilation requirement, we go through confined space requirements and procedures in Part 1. Those who are not yet watched Part 1 and Part 2 of confined space training program, we recommend you to go through that so you will get overall idea about confined space requirement. This is confined space part 3 gas monitoring. So let us begin the program. Please watch carefully. If you have any questions, doubts, you can comment that in the comment box. We will clarify your doubt. Thank you. So first we will discuss about what is gas. The name gas from the word chaos. Gas is a sum of molecules moving randomly and chaotically, constantly colliding with each other and anything else around them. Gas fill any available volume and due to the very high speed at which they move will mix rapidly into any atmosphere in which they are released. The normal atmosphere. Let us see what are the gases contained in our normal atmosphere. Nitrogen, that is N2 symbol, about 78% of normal atmosphere contain nitrogen. Oxygen is about 20.94, argon is 0.93, carbon monoxide, that is 0.031, neon, it is 0.0018, methane, that is 0.002%, helium is 0.005% and krypton is 0.0011, hydrogen is 0.0005% and xenon is 0.00087%. Gas hazards. There are three main types of gas hazard. The first one is flammable, risk of fire and or explosion. Examples are methane, butane, and propane. Toxic, risk of poisoning. Examples are carbon monoxide, hydrogen, and chlorine. Asphyxiant, mean to say that risk of suffocation. Oxygen deficiency or oxygen can be consumed or displaced by any other gas. So let us discuss about fire, how it will occur. Before the fire, it is triangle. Now it is tetrahedron. For many years, the concept of fire was symbolized by the triangle of combustion and represented fuel, heat, and oxygen. Further fire research determined that a fourth element, a chemical chain reaction, was a necessary component of fire. The fire triangle was changed to a fire tetrahedron to reflect this fourth element. A tetrahedron can be described as a pyramid which is solid having four plane faces. Essentially, all four elements must be present for fire to occur: fuel, heat, oxygen, and a chemical chain reaction. Removal of any one of these essential elements will result in the fire being extinguished. Mean to say that if you remove one of these elements, will automatically put off the fire. Let us discuss about LEL and UEL. LEL is lower explosive limit and UEL is upper explosive limit. The minimum concentration of particular combustible gas or vapor necessary to support its combustion in the air is defined as lower explosive limit. Below the lower explosive limit, that gas is very or too lean to burn. UL, that is upper explosive limit, highest concentration of a gas or vapor in air capable of producing a flash of fire in presence of an ignition source, arc, flame or heat. Concentration higher than UL are too rich to burn, also called upper flammable limit. Let us go in deep flammable limit. At level below the LEL, there is insufficient gas to produce an explosion. The mixture is too lean, as we discussed in the earlier slide about LEL. The vessel above the UL, the mixture has insufficient oxygen. The mixture is too rich. So that's also another case. The flammable range so far between the limits of LEL and UL for each individual gas or mixture of gas. Outside this limit, below LEL or above UL, the mixture is not capable of combustion. It means to say that if the gas LEL is below that, or the gas UL is above the particular limit, mean to say that that will not capable of combustion, which is very clear. So the picture you can see that too rich, too lean. Mean to say that below LEL it is too lean to burn. If it is above UL, it will not support or it is not capable of combustion. So it is in between UL and LEL. Okay. CO mean to say that carbon monoxide is a colorless, odorless, tasteless and combustible gas with a lower explosive limit value of 12.5%. If it is below that, then it is too lean to burn. Hydrogen sulfide is a colorless, flammable, and extremely hazardous gas. It is heavier than the air. It has odor like rotten egg, and the lower explosive limit value is 4%. Below that, it is too lean to burn. If you want to enter a confined space, you require to have minimum 90.5% of oxygen and maximum is 23.5. In between, you require to have oxygen level inside the confined space. If oxygen percentage is below 90.5, that is called oxygen deficiency. If it is more than 23.5, that is called oxygen enrichment. Both cases, you are not supposed to enter the confined space normally. Otherwise, you have to have a risk assessment and prior approval from your client. And you will have to wear additional protective devices like self-contained breathing apparatus when you need to perform activities the oxygen if it is oxygen below 90.5%. Let us see what will happen if the oxygen level is below 90.5 and above 23.5. If it is 23.5% above that, as we learned, oxygen is enriched. There is a chances of fire hazard. If it is 20.9, that is normal air. 90.5 is minimum permissible oxygen level. You can enter. If it is in between 15% to 19%, mean to say that may impair coordination and may cause early symptoms of persons of pulmonary and circulatory problems. You feel difficulty of breathing. 10 to 12%, respiration further increase in rate and depth, poor judgment, blue lips. If it is 8 to 10%, mental failure, fainting, you may unconscious, nausea and vomiting. 6 to 8%, recovery is still possible after 4 to 5 minutes. 50% fatal after 6 minutes, fatal after 8 minutes. Mean to say that if it is below or if it is 6 to 8%, recovery if possible, it is not guaranteed.
4 to 6%, coma within 40 seconds. So that means that if the oxygen is below 6%, fatality may occur. That's why it is important to do the gas monitoring before you starting the work inside the confined space. If it is below 90.5, severe precautions has to be taken. You have to develop a risk assessment before starting that job. That is very important, and get the approval, and necessary rescue plan should be developed in order to perform the job inside that if it is below 90.5, and it is not recommendable. Some cases it is recommendable because it is unavoidable to work inside the confined space, but still you have to take the precautions like self-contained breathing apparatus. That is the source of oxygen that you require when you're working inside the confined space. However, normal construction sites below 90.5, it is not acceptable, and above 23.5 the same way.
Okay, let us discuss how to use the gas detector. I bring a gas detector to show you how to use that in a proper way. This is Ray 3, it's a good brand. So we are using currently that in our project. So we will unbox that first. Okay, we'll remove the cover first, keep that aside. Then you can see that it will open the box. Okay. When I opened that, I got one card. That means register your product online. You can register the product online in their site. And we have a quick startup guide. So it will show you step by step how to use that. Then if you can use that, you can use that. Also, we have a CD. You can play that in your laptop or in your PC. And we have one tube that using for calibration purpose. When you're doing the bump test or calibrations, we can use the tube, and we have a clip on that. It should be attached to the gas monitor when you're performing the calibration or bump test. We do have charger in place. Before you are using the gas monitor or gas detector, you have to make sure that it is charged. And we do have a gas monitor. Yes, here is our gas monitor. See, very good, right? Okay, so let us switch it on if this is charged one, right? Okay, press here. Okay, a long press. 1, 2, 3. Beep down, beep sound. Okay, it's self test. Self test. 1, 2, 3. Okay, it is pass. Self test is pass. Okay, then it's going to be sensor is warming up. It take about 53 seconds. So let us discuss other matters. When you are performing any confined space activities, it is mandatory to conduct gas monitoring before you start the work. Who will perform that? Unauthorized gas tester will perform the gas testing in the construction sites or in the greenfield or refinery. But in the processing plants, those employees are entering the confined space, they must carry, that is called continuous gas monitoring. But in the greenfield, there is some considerations. I mean to say that it's when you are working inside the confined space, before approving the permit, a authorized gas tester must conduct gas testing by using a gas monitor. Whenever you are using the gas monitor, please make sure that it is calibrated and having a valid calibration certificate. That is the responsibility of the supervisors, and it has to be ensured by the HSC representative at the site. Okay, it shows that quit or start. Let us start it. Okay, you have to press yes button. Okay, now it is calibrating. You can see that it's take about 25 seconds. Now it's counting down 20, 19, 16. So the machine itself doing the calibrations before it start up. So normally the calibration is doing by the third parties, the approved third parties in the countries. Okay, you can see that now it shows the level of oxygen. Okay, 0 results showing that, mean to say that you can see the results. We found the results. Carbon monoxide 0, hydrogen sulfide is 0, LEL 0, and our oxygen level here is 20.9%. That's where I am sitting. Okay, it's very clear. I think that there is some glares, hoping that you can see the clear picture in this. Okay, that is 20.9. You can now you have a clarity in your video. See that zero is low, 0, hydrogen sulfide is 0, LEL is 0, and the oxygen level is 20.9. That is a normal atmosphere contained. So this way you have to do the inspections. Okay, I will show you one more thing that is pretty good, interesting. So we will clip this. You can see that it has to be clipped here, right in this portion. Okay, you keep it like this, then tight it up, then press. Okay, I'm going to do one thing that is pretty interesting one. See that tube which we how just insert that to here. Okay, then I'm going to blow it. Okay, blow the air. See that? Go to carbon dioxide, right? So, mean to say that another gas comes, the oxygen levels comes down. You can see that is 16.1, 15.9. Why it comes low oxygen? Because I blow all carbon dioxide through this tube, and it is detected in the, mean to say that it's enter the gas monitor. So automatically oxygen level come down. Now I'm doing nothing. Okay, now normally it's back to the normal state. The oxygen is back to the normal. See that it's increasing, 80.8, 80.19, 19.1, 19.3. When it reaches 90.5, the alarm will stop. See, it's reached 90.5. Oh, it stopped. It's working. It's good one, right? This way you have to do. I just show you how it is to make sure that your sensors are working properly. Okay, so that's all about. I hope you enjoy this this video.
Thanks for watching, and we will continue.